adoption. It all starts with some trigger, and then early adopters begin to sell it as a silver bullet to all humanity problems. And with times go by, and we receive the bubble of inflated expectations. When this technology fails to deliver actual promised value, we all think that, okay, it's not a silver bullet, so let's look for a next one. If technology works, it slowly becomes more popular and find its way on the market. And I am usually working in this area of this chart. So I'm focused on some ideas and technologies that is not commonly used, that's not presented, and I want to push some technologies and not to just pick up the latest thing on the market. Sometimes it's worth it, but sometimes it's not. It's always gambling with high risk, high reward. And 2 years ago, I saw the rise of unidirectional data-driven architectures like Redux, Mobix, Elm, Cycle.js. These ideas become extremely popular with the rise of single-page application pattern on a web platform. Because single-page application is actually more like native application where we need to handle state during the session. Otherwise, classic web application doesn't require you such handling complex operation, routing inside, and so on. So they all aim at similar problems, how to maintain the state, and they offer actually similar solutions. You can, and I start to think about reasoning behind it. So why idea of unidirectional approach becomes so popular? How can I use its benefits in iOS, in day-to-day iOS development? All these ideas, they have pretty common and simple structure. You need single source of truth that accumulates the whole application states. When it's one, you cannot have any synchronization issues because it's single source of truth. And you have single place of change where all mutations are applied to the state. Again, if the single place, you know where to look for your code. You can quickly find the reference code and do it. And also you have single way to receive updates from the shared state. So core of your application is basically 3 items. How to store the state, how to mutate the state, and how to transfer updates to all other participants. And these approaches are focused on answering one very important question. This is what is going on? Why my application ended up in this state? Why this button is visible to me? What series of events occur that we can see this? These questions are most time consuming. And this believe that this the most important questions, because until you can answer this question, you cannot fix the code because you do not understand what's going on. So these questions, I call them debug questions because you often ask them during debug sessions when you see this harm behavior and you want to change it. And debug process consume way more time and mental resources than writing code in first place. Simplifying this huge part of your day-to-day routine, even a little bit, will be a huge time saver for any project. And I realize this is exactly what I need to become the more efficient developer. If I can change my code easier and faster, then I can lower the cost of change. And the cost of change is the main money consumer during development. This is my ultimate goal with every product development, make cost of change as low as possible. So today I want to share with you my lessons during these 2 years of practicing this approach. These 5 lessons that I learned and my 5 pain points that I hit on my path. Let's deep into details of each of the lessons one by one. First of all, we will start from structuring our view layer. 80% of time is usually spent inside the view-related tasks because user interface is central topic of any modern application. Traditionally, in MVC, UI view controller is responsible for managing all async operations related to this view. So, as you can see, we'll have some identifier of our data inside a database. I believe this view controller will fetch some data using this identifier, then, for example, synchronize it to the API. This approach has some very serious problems. First of all, it leads to a lot of intermediate state inside of your view controller. So your view controller need to maintain several async processes at once, and it's can lead to very fragile situations because you can have like multiplication of every possible state. And as soon as your view is not changed in one place and mutation to your actual view layer are distributed a whole the big view controller, it's hard to understand why exactly this view end up in the state, because there can be combination of different mutation in different points. In my opinion, this is the main motivation to switch away from traditional MVC approach. Not the stability one, but inability to answer this question quickly. What causes this bug? What's going on? So the next step on my journey is MVVM station. I practiced MVVM for 3 years with reactive approach, and it allows us to move all data handling into separated entity and leave binding only in view controller. It's really great to use this MVVM with different reactive programming frameworks, because reactive programming allows you to express the data structure of your application in terms of streams. And what we do with this view controller, we have some view model now, and we can observe the change of view model, and we can observe even the change of single elements of this view model. And we can mutate these elements. For example, I expect birthday to increase the current age and marriage to change the current name. So we can interact with it, and our view controller becomes much more simpler. But this approach is definitely a solid step forward. But even it has several issues. Like, it's next level of issues. You can never run out of issues. You just solving one of them, you receive a new one. When view model is changed for some reason, it fields changes one by one. For example, name first, then age. And for some short period of time, your view model can end up in invalid state. So imagine you have two flags, and they will be changed independently. But by your design, this can be only specific combination of these flags is allowed on the UI. So you can render not all states. And this is called transient states, where you change something and you see the cascade of changes inside your model, and you need to look at them and somehow interact with them. Another problem is the sharing view models between view controllers. You again receive the same logical data races, but on a level of multiple view controllers. Because traditional MVC have logical data races in one view controllers when two async operations going on simultaneously. And on MVVM, you have logical data race on several view controllers. And I believe that reactive paradigm itself is a challenge for many teams. It encourages you to represent the state as a collection of data streams. And having this often leads to unpredictable chain reactions inside the code. So small change in one part of application can have unpredictable results in other parts because everything is interconnected. To address this issue, alongside with Redux development, I was inspired by Redux approach. I started to use data-driven view controllers. To avoid transient states, I decided to update whole model at once. So now the view model is just data, and it cannot be updated partially. It will always update it as whole, and all that we will do is just request layout phase. So when our view model is changed, we just request new layout phase, and then inside view layouts of views, we perform all rendering from the view model to actual UI layer. And we even can represent actions as a data. For example, birthday and marry, it still can be used as a functions inside the view controller, but we don't know what these functions will do, because it all depends on who creates this view model for this view controller. To break dependencies between several controllers, I applied the value semantic and nested types. So as you can see, every view controller should have its own view model that does not correspond to another view controllers. So its only property, its only responsibility of view controller is to render this view model. And the only reason to change this view model interface is changes inside the view controller. So every external change in your system will reflect only at the layer which creates this view model, but not inside the controller. This creates a strong decoupling between view layer and your model layer. For example, this allows you to render any view controller of your application with any view model without the whole application itself. So you can just instantiate some view controller, render it with some random just view model without connection to services and so on, and look at your UI, debug your corner cases quickly. It's short feedback loop. And big benefits, this approach does not require any framework adoption. It's simple, straightforward, it's just some limitation, one single rule basically, that every view controller should be data-driven. This is lessons that we learned hard way, because having data-driven actually speed up our change and our development flow a lot. Next topic, I want to talk about that view models itself. Now we learned that our view model should be data-driven. Okay, but how to represent UI state with pure data? It's not a simple task, because, for example, let's look at this view model. It has several flags. It has several actions, login, logout. But this model can easily end up in some weird states. For example, what should logout action do when you are loading state? We don't know. UI doesn't know how to react to the state. We cannot easily render this without any corner cases. And we can avoid answering all these tricky questions by just structuring our view model in a way which allows only valid states. So we can easily represent it as a set of different options. And for example, login form will have only one action associated with it, login. So we cannot perform login operations if our view model is not in login state. And we cannot perform logout operation if we're not logged in. This technique calls making impossible states actually impossible. There's a lot of impossible states. When you will start thinking about it, you will see them everywhere in your code. And this is common source of bugs, not only in view layer, but actually any part of your application. If you're interested in more deep introduction to this topic, I dare you to watch this video. So every link with underline is actually a link. You can download it and watch it later. So this is talk about the actually making this. It's showing the Elm language, and Elm is heavily was inspiration for Redux in first place, and it's actually data-driven architecture for web frontend. I want to share some real-life example. This is a portion of code from our open-sourced SDK for video player controls. As you can see, our props is the same as view model. It's just a different name. It's cases of has several cases. no player at all, some player, and picture-in-picture mode when not all controls is available. And player itself contains playlist, which contains different actions like next and pref. As you can see, we can infer visibility of a button just by do we have this action or do not have this action. And some item inside this player can be playable or non-playable if something goes wrong. So you cannot have, you should need to display an error message to user and not to display SIGBAR and so on. So this is a pretty complex example, and it goes much deeper to it because it also has controls which has different options like SIGBAR and so on. It's like a really big structure. But this model is correct and expectable. So every value of these props will be correct, of course. But is it easy to render? Is it easy to unpack all these enums, extract values, and render it basically to the user interface? We learned that it's not so easy. It's easy to make a mistake. What is it to render? So these props will be easy to render for us. Just login button action, login button enabled, flags, yes, no, visibility, non-visible. If our previous view model was focused on data that is represented on the screen, this version is focused on actual UI structure, because it's now which view you have, how you implement different actions, and so on. And what is most important stuff, that your props can be created only with the view model. So it's like a second layer more closer to the actual UI implementation, and you can basically cover this transition with unit tests, for example. And you will have a simple transition from one structure to another structure. But if first structure represents the deeply nested and complicated data, this represents just the state of the UI. And this props is much easier to render. It's just straightforward application. So this is some real life example that we have some props loading, and this is how we unpack all this data. We learned that having this structure where you process one property at a time instead of going, so I'm calling it from the target to the, from the output to the input. We're not writing our code in the first place by switching by these enums. We're writing our code in the first place by extracting what we need. Because in this case, compiler will help us. Basically, if we add or remove some properties, we have this heavy isolated chunks of code that we need to change. It's easy to locate place to change. It's quicker to make a change. It's lowers the cost of support. So we can use the best of both worlds. We can have correctness of state by exposing correct, deeply nested and complex view models, and we have simplicity of rendering by converting this view model to some UI view model. And this allows us to write some tests. So second lesson that we learned, that correctness of values should be enforced with types, not only in case of view models, but every type should be, every possible habitant of your type should be correct in your logic. This is the main reason of having types. Next lesson will be about data and event duality. This was some strange like discovery that you can represent every data as a stream of events. Basically, if you will have stream of events one by one, you can add up these events and you will receive some state. And you can represent event as a difference between two data, two snapshots. For example, if you have account state, you can track this by applying different events like withdrawal or deposit. Or you can infer the event just by looking to account states. What they are convertible, but they are not equal, because events are very fragile. Order in events are very critical. if you change order of two events, you will probably change the meaning of a whole chain. And context is also important, because place where you emit some event and place where you handle this event, they can have different contexts, and meaning of event is determined by its context. So you can probably handle it in wrong way. Errors are cumulative, so one error inside event stream will break the whole stream. However, data is way better than event, because data has no order constraints. Data is self-sufficient as it is. We can miss some data. We use it a lot. For example, our view model is generated only when we actually receive some main screen, some main thread updates. So we don't need to transfer all state inside the view model, because we can miss some. It's not a problem, because our state contains all that we need without reference to previous states, so we never look back to different data. And data will be eventually okay. If you miss something, it can recover from errors, because if you receive corrupted data, you will just wait and you will receive the new data. Because if you receive one single corrupted event, it will corrupt the whole your state internally. So some real life example, you can go by this link, and we managed to wrap AV player API in a data-driven manner. So this heavily callback-based API, how to control the AV player, when to change to different URLs, when to perform play pause, and so on, is just covered with this props, data-driven, and we have open sourced it, so you can learn how to use this approach. Inside your application, there will be some event sources, like external systems, user input, different side effects. You cannot avoid events. But as long as they come into a system, I believe you should avoid events, generating events inside of your system. Instead, you should have single data source. So this formula showing how we can represent the data in the form of stream of events. And if we will write the code for this formula, it will be pretty simple. We can have application class, which has some initial model and can apply events to this state once by once. This is the core idea behind the Redux approach. So you have a single place where all mutations to your single model is applied. There is the only way to change the model. And this is my third lesson, that single data that you receive should be enough. Otherwise, you will end up looking for difference, and this is so vulnerable for thread issues, for lifecycle issues. For example, if your view controller is dead for some short period of time, you don't have a link to it, it can no longer maintain the internal integrity, and you should freeze the resources. In case of data, you just receive the new data to the new view controller, and everything is the same place. The fourth lesson is about having dependencies. Usually, there is several practices how to handle dependencies. The first and naive is having singletons. Singletons is pretty simple. You do not need to do anything much more than just declare something as a singleton and then use it somewhere else. But singletons have unclear usage. You don't know how singletons are used across your application. They can have shared state, and so you will receive the logical data races again. And the singletons can miss of context. For example, if your singleton requires some configuration, the different parts of your application may not know that configuration was done or not. So it's again logical data races. The next step on a dependency management problem solution is the dependency injection. Okay, now we will have some protocol and we hide all dependencies in a protocol. I believe the dependency injection is a solution to a complex problem, but when it grows, it's become hard to manage these dependencies. You will end up in like 10 or 12 or 15 dependencies. And you will receive transient dependencies because some of your components require some dependencies. You will declare that you require these dependencies. And dependencies in case of DI are often connected to some interface. For example, if you will decide to switch from one network interface to another, probably you will force to update your API client. It's usually you cannot predict all ways how your API will mutate. So this is some example code how we can write our logic with a dependency. We have login function, which will get from API client methods, pass parameters, and handle the states calling show alert or push user page. So actually, this code violates single responsibility principle. In this dimension, this code's answering two questions at once. First question is what I need to do for login. The second question is how I need to do it for login. Because actually having this hidden behind the protocol doesn't solve this. You're still telling how I need. So you need to go to this instance and call this method, and in callback perform these actions and so on. What if we separate the first part, what I need to do? For example, this is a list what is going on inside this code. This is some get some pass params with callback. This is some show alert with error, push user page with value, and do nothing. So we separated it. And now this is just a recipe, again, pure data. And our login function is now looks like this. So just we return some effect now. And in case of get session params, we'll handle that if error, we return next effect. As you can see, our callback now also forced to return effects, and somehow we can chain async actions in this declarative manner. And that's it. You have actually your login function doesn't do anything at all. It just declares what needs to be done and does not telling how it needs to be done. Do you remember our application class? So it can apply events and we can add the perform of effects. And now our application is a single place where all effects is performed. So it allows us to have any implementation behind these effects because it just declares what needs to be done. It doesn't even imply how it needs to be done. So my fourth lesson is about separating how and what. The last lesson will be short and more about testing this approach. It's easier to start unit testing the data-driven architectures because it's always data in, data out, nothing extra. It has low support cost even because they're so much decoupled from each other that changing in one part of application usually requires you to update only this test for this part. You will not have this chain broken tests. But this unit testing actually show you nothing except that this small chunks of code works. Why? Because it doesn't show you how the models interact with each other. What is the order of function calls? What is the order of real data flows inside the whole application? That's why we have integration tests. It's usually hard to write. It's pretty costly. So you end up with covering only some critical sections because it's hard to adopt. What we can do with our data-driven integration testing? Well, we have single place where all actions performed, so we can record. We can record every model that we hit. We can record every event that comes into our system. We can record every effect that's come into our system and so on. And we actually do this inside one of our projects. And this is information about shared, like the single use case. And as you can see, model JSON is 35 megabytes. It's around 500,000 lines of JSON code, which represents the whole states during the execution of this use case. What we can do with this data right now, we can use it as an input for our system. We can start the application and SU it and use the all events as an input. So we'll generate the same events and we will check that the same model is generated one by one. So we can use data as rules, assertions for our tests. If our model is basically the same and we perform the same effects, then observed behavior of our code is not changed. It's really helpful when you want to perform some refactorings and you need to know that your behavior will not be changed. During this case, we have several use cases recorded and the test just run and run. You can record this events just by enabling the tracer, and then you will use your application sometime and the whole list of events will be recorded. And you have just like user validation, user story, what's going on in terms of your events internally. We call this verification testing because it's basically verifies that behavior of your system is the same. It doesn't allow you to design some behavior upfront because you cannot write some trace before you have this actual data. So my fifth lesson is about that unit tests are not enough. If you want to be sure that your application is predictable, then please write some integration testing. But it's costly. But again, with power of data-driven and Redux, you can lower the cost of this test because it's really cheap to write this. It's like 200 lines of code for this test. So that was my 5 lessons. And I want to share some useful links with you. First of all, it's idiomatic Redux by creator of Redux, Dan Abramov, where you will find how to build the applications with the Redux, how to structure a state, and so on. Then there's our open source components for video player and video renderer, which is where you can look at this in real world case and examine how you can maybe apply. And please check out the Elm language. Elm language is a small language designed specifically for this kind of architecture. So it's like a language designed for architecture and not vice versa. I want to share some community efforts. It's first of all, it's a curated list of Swift frameworks for connected with Redux and Elm. It's created by Yasuhiro Inami, and it's really awesome if you want to start. It's just like dozen of frameworks with downsides, with virtual DOMs, frameworks and so on. You can just open and experiment with them. It's article by Matt Gallagher about the statements, messages, and reducers that will show you exactly the same approach, but more applied to some state management side. And reducers by Chris Eidhoff, which will show you how to can leverage managed side effects, this commands side effects stuff, for dealing with async actions. There is even open frameworks which you can start to use, like full featured framework for Redux and Elm-like applications. Katana featuring the virtual UI, so it doesn't connect it to UIKit at all. You can just represent it like in React.js, represent the virtual DOM of your user interface, which then will be rendered to actual interface. It allows also featuring data-driven layout and strong foundation for your experiment if you're interested in this kind of approach and want to pick something working already. Also, Portal by Guido Marucchi, which is Elm-inspired framework instead of Redux-inspired framework. It's also have managed side effects, data-driven layout, completely type-safe. If you have some questions, you can ask now on Twitter or send me a mail. I really love to receive some feedbacks after my presentations. Thank you for your attention.
А сейчас есть ли какие-нибудь вопросы?
Okay. Thanks a lot, Alexey. Cool stuff, really. Question about integration tests. Really like smart thing and idea. And so what happens if I'm not doing just a refactoring, but I'm doing a change in a model? Do I have to record my all the integration tests again?
Okay. If you have the change in how you generate your side effects and your models, you will just receive a thoughts. This is actually a difference, and you can look by this difference and say, well, okay, this is expected change, so now this version will be correct one.
So you have some kind of diffing tools, like for snapshot tests?
It's two JSONs. Okay. You can just fill it in some differ and actually see the difference. Sometimes it's hard to understand if you will just revamp everything. You will see the completely different JSON. What else we're working on, because it's like represents every state like snapshot, it's not very useful because usually your action change just a little bit of your state. So we want to represent it as a diff between the previous state and so on. And we will work on it. It will be more manageable, but it has some downsides, but we start to use it. We have several cases recorded this way, and the real use case behind it that we start to rewrite part of our application on a JavaScript core. So we use this as verification. The JavaScript part will have the same behavior as a native part, because we want to make it common between different platforms. Yeah.
Cool. So I assume you didn't have the whole like approach outline in your head from the beginning when you began to do your real life project. So how long it took for you to get some like valid, stable approach?
Okay, so it's like several layers. I have started from data-driven view controllers, and then I experimented a lot how to represent the state of application. And when I found the stable way to represent the state, then I started to think about side effects and how I can represent the async process inside. Because initially you can have just a state separately and perform all async operations inside your view controllers. Like Flux and Redux, they promote this action creator when you actually inside your view controller will just start a async operation and execute not a single event, but for example, future of event. So this path of some experiments, and I believe these outcomes are very context specific, because given our context, our projects, and our team, we reach one outcomes. But having the same ideas, the same values inserted in different teams will probably end in different outcomes and different general shape. But that's why we don't use any framework for Redux. I believe that ideas behind this, the debug simplicity, the data-driven for quickly understanding what's going on is much important than any framework selection. So if you will utilize these values in the first place, any decisions that you will come up working for you will be a good decision, because values are good.
Yeah, cool. And last question from me. So any drawbacks, any problems with performance or something else?
We hit the problem with performance when we try to render on every change, and because you actually can have that your view model will update several times per draw cycle, and you will render and render, is basically doing the same work, and we quickly fix it by integrating into layout loop of a UI kit. So you're just asking for new layout phase, and you actually perform rendering during layout phase. It's pretty simple. The another drawback that we had some from time to time we have cycles of this architecture when system just freeze because some reaction to the new state generate event which trigger new reaction, and in certain cases we have these cycles which actually it's not recursion because you actually on the same level of stack. So it's like run loops. Okay, I do this. So it's really hard to detect, and usually detect all application freezes. Okay, you just look at the journal of events. Yes, we have some cycle. What is possible to do? We have some ideas how to deal with it. You can write sanitizers for your stream of events and sanitizers for your stream of data to just verify that everything is okay. Because it's just data, you can write a logic, debug logic, like in Xcode 9 when you have sanitizer for data races. It just looks the same stuff. It converts access to data to the stream of these events and then just sanitize them. But everything is okay. You can do the same for your business logic. Yeah. Any more question? Okay. So if you want to discuss this or some advanced topics, for example, how to implement cross-platform core for your applications, how to integrate with existing tooling, Redux DevTools and so on, and how to start adoption in teams for this approach, you can always find me during this wonderful day of Mobile Optimized. Thank you.